So the first thing I'm going to do is factor using special patterns. The first one is the difference of two squares pattern. For example, if you have an a squared minus b squared, you would factor it into its conjugates. What the conjugates are is you simply take this a squared, the first term, and write the square root into each set of parentheses. The square root of a squared is a, so you write that twice, and then you take your b squared, find the square root of that term, write the square root twice. The square root of b squared is b. Then you put a plus and a minus, just as you see here in this pattern. Now that's if you just have letters. Let's look at one where we actually have a variable and numbers. Here we have two perfect squares, x squared minus 9. The square root of x squared is x, so I'm going to write it right here, x, my first set of parentheses, and write x as the first number, or the first term, in my second set of parentheses. I then take the square root of 9, which is 3. I write 3 and plus 3, and then I write x minus 3. And I'm done factoring the difference of two squares. So let's try a few more of these to see what they look like. Here we have x squared minus 16. We're going to take the square root of x and the square root of 16. We end up with x plus 4 times x minus 4, and we're done. Do p squared minus 144 on your own. Remember, the square root of p squared is p, and the square root of 144 is 12. On c, we have 4y squared minus 81. You can have a coefficient, and as long as it's a perfect square, you can just take the square root of that term also. The square root of 4y squared is 2y, so I write that in my parentheses. And then I take the square root of 81, which is 9, and I write plus 9 and minus 9 to get the factored form of 2y plus 9 times 2y minus 9. And here's one more to do on your own. Please feel free to do 9m squared minus 25 on your own as well. Please bring the p squared minus 144 and the 9m squared minus 25, the factored form of both of those, to class on Wednesday. Let's go to our next pattern. Here is another rule, one that you should probably have not seen before. We are going to factor the sum or difference of two cubes. Cubes are numbers that are perfect cubes. If you take x times x, you would get x to the third. And if you take y times y, you would get y to the third. So the pattern on these is that you would take the cube root of x to the third. In other words, what number did you multiply by itself 3 times to get x to the third? In this case, it would be x. So I write the cube root of x, or the first term, in the first set of parentheses. Then I take the cube root of my second term and write it at the end of the first set of parentheses. I then look at this x that's in the first set of parentheses, and I square that term. I square the x and get x squared. I multiply the two terms in my first set of parentheses. I do x times y and write it in the middle of this trinomial. I then will take the last term in the first set of parentheses and square it and write y squared. From there, I would Look at the sign. This was the difference of two perfect cubes. So I take that and I write same, opposite, opposite, or SOO. So, same sign, opposite sign, or minus, plus, plus. Let's look at when we have the sum of two perfect cubes. What we'll do with this is the same pattern, where I take the cube root of the first term, and the cube root of the second term, and write those in my first set of parentheses. I then take these two, square the first term, and write it here, write x squared. I take my second term, multiply the two together, write it as the middle term of my trinomial, and then square the last term and write y squared. My pattern for the signs of the sum of two cubes is plus, minus, plus, or same, opposite, plus. So my two patterns here for my signs is same, opposite, opposite. That looks like a 5, but that's an S. And then for the sum of two cubes for my signs, it's same, opposite, plus. So and sup. Okay. So let's see what these look like when we put some numbers in them. Where are they? Here they are, all the way down here. And I have x to the third minus 1,000. These are both perfect cubes. I'm going to take the cube root of x to the third, and I write x in the first set of parentheses. I have 1,000. The cube root of 1,000 is 10, because 10 times 10 is 100, times 10 is 1,000. So I write the cube root of 1,000 in the last term of this first binomial. I then square my x squared. I multiply 10 times x together, and then I square my 10 and get 100. I look up above, and I see that this is the difference of two cubes. So I write same, opposite, opposite on my signs. I do the same, I do a minus sign, that's the same here. Oops. And then I do plus, plus. Here is the sum of two perfect cubes. Sometimes you do have coefficients, and that's okay. You can use the same pattern as long as that coefficient is a perfect cube. The cube root of 64 is 4. So I write the cube root of 64x to the third, which is 4x. And I write the cube root of 27, which happens to be 3. I then take 4x, square it. I multiply 3 times 4x, which is 12x. I square 3 and write 9. And from there, I use my pattern. This is a plus. I look up above. I see that when I have the sum of two cubes, I do same, opposite, plus. So I use the same sign. I put a plus in my binomial. I do the opposite sign between my first two terms of my trinomial, would be a minus, and then I do a plus sign between the last two terms. And I have a couple more examples for you. If you'll notice, the one difference here is when I have 3x to the third minus 3. At first, I didn't think I could do that one until I saw that they have a greatest common factor. My greatest common factor is 3. So my first step was to factor out my greatest common factor, and I had 3 times x to the third minus 1. I then saw that x to the third minus 1 is the difference of two cubes. So I then factored x to the third minus 1 using the pattern above. So take notes of these examples and see how you do on these. The good news is I only have one more page to go. So let's go ahead and look at these. This is factoring by grouping. We already did some factoring by grouping in class on Monday. It was with trinomials. Well, here we don't have a trinomial. We're going to have a quartic. That is, it's a polynomial that happens to have 4 terms. Sometimes we can factor a quartic by grouping. So here we have 4 more terms. We're going to group terms in pairs and then factor the GCF of each binomial and use the distributive property to undistribute and write the factors. My first example is x to the third minus 3x squared plus 4x minus 12. So all I did was write parentheses around the first 2 terms and then write parentheses around the second 2 terms. From there, okay, come on screen, move down. I factored out the GCF of the first set of the first group. I saw they both had x squared in common, factored that out. I saw that 4x minus 12 has a 4 in common. I factored that out. And then I undistributed because I had x minus 3 in the same thing in both sets of parentheses, which is really exciting because that's what we want. When that happens, we can undistribute. And what I'm going to do is take the x squared and this plus 4, put it together in one set of parentheses, and then write the x minus 3 one time. Does it look familiar? Okay. So here I have another example for you. Actually, 2 more examples. Okay, the first one. See if I can move my screen over this way. Okay, oops, I have messy ones. Oh, it's already partially done for me. Look at that. I didn't notice that. Here we have a 3a times a plus b minus 2b times a plus b. So all I have to do is undistribute that a plus b, and I have a factored product. Same thing with number 2. It's already partially factored for us. So I'm going to put the 5ab plus 4 together and the 2a minus b right at once. But not all of them that I have here as examples are done for us. Let's look at number 3. Okay. I have 4ax plus 14ay minus 10bx minus 35by. Lots of stuff going on there. So I am simply going to put parentheses around my 4ax and my 14ay, put parentheses around my 10bx minus my 35by, and factor out the common factor. One thing you might notice here, on this minus 10bx, I crossed the line and changed the sign, so I have plus negative 10bx now inside my parentheses. So what I did is I simply factored a 2a out of my first binomial, and I got 2a times 2x plus 7y. And I wrote plus, and I factored a negative 5b out of the second group. By doing that, it turned that into a positive 2x inside, and the negative 35 divided by negative 5 becomes positive 7. I now have the same thing inside my parentheses, so I'm going to take this 2a and my plus negative b, write that together inside one set of parentheses, and the 2x minus 7 I've undistributed, and I have in my next set. So I guess I'll see you in class. Please try some of the example